In Python, the time complexity of algorithms can significantly impact the performance of your code, especially as the size of the input data grows. The big O notations O1, ON, and ON squared are used to describe how the runtime of an algorithm scales with the size of the input. In this video, we will compare these complexities with simple examples. First, let's compare time complexity and space complexity, which cover different aspects of an algorithm regarding performance. Time complexity refers to the amount of time an algorithm takes to complete as a function of the input size. Space complexity refers to the amount of memory space an algorithm needs to run as a function of the input size. In this post, we will only cover time complexity as it's more commonly encountered in practice. Then let's understand what is the big O notation, which sounds a bit mysterious. The O in big O notation stands for order of. It provides an upper bound on the growth rate of an algorithm's resource consumption, time or space, as the input size increases. The common forms of big O notation include O1, ON, ON log n, and ON squared, which will be explained with simple but practical examples soon. The first big O notation we will introduce is O1, which means the execution time remains constant regardless of input size. Some common examples in Python include accessing an element in a list by index, checking if a key exists in a dictionary, and checking if an element exists in a set. Understanding O1 is very important as it can help us write more performant code using dictionaries and sets. The second common big O notation is ON, which means the execution time grows linearly with the input size. Basically, it means a simple for loop is used to iterate over all the possibilities. For example, the time complexity for checking if an element exists in a list is ON, because in the worst-case scenario, we have to compare all the elements in the list with the given element. As you may have noticed, the time complexity to check if an element in a set is O1. So why is it different for lists and sets? This discrepancy arises due to the fundamental differences in how lists and sets are implemented and how they handle membership tests. In Python, lists are ordered sequences of elements and are implemented as dynamic arrays. On the other hand, sets are unordered collections of unique elements and are implemented using hash tables. The hash value of the element to be compared is calculated and then compared with the hash table of the set in memory. You can understand a hash table as a dictionary in this case, whose keys are the hashed values and the values are some constant. Similarly, for ON squared, it means the execution time is proportional to the square of the input size. In most cases, it means two for loops are used to iterate over all the possibilities. As shown in this code snippet, we may loop over the same list twice or loop over two different lists. The time complexity for both cases is ON squared. This is a very expensive operation, especially for large data sets, and is normally a bottleneck of the code that needs optimization. In many cases, we can change the data structure to dictionary or set to avoid the nested loop and change its time complexity to O1 and the total time complexity to ON. For completeness, let's also introduce ON log n, which means the execution time is proportional to n multiplying log n, with n being the input size. This time complexity is most commonly seen in various sorting algorithms like merge sort, heap sort, and tim sort, which we normally don't need to worry about directly in our code. For example, when we use the built-in sorted function to sort a list, the time complexity is ON log n. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content.